And next, we want to discuss the polynomial regression for logistic model. So logistic model has binary response variable. So we want to choose this null data again, but we want to fit whether or not the value is more than 1000. So basically, we set a threshold and we want to calculate the probability that the water level is more than the 1000 at given time point. So we have some observations here and some observations here. So possibly probability is higher, just higher in the beginning, or maybe higher in the beginning and near the end. So logistic regression model. So basically we fit the probability of y is equal to 1. Here the null is larger than 1000. And we fit this as so-called inverse logit function of polynomial of x. So beta 0 plus beta 1 x plus beta 1, beta 2 x squared and so on. So this is the logistic regression model with polynomial. So basically we can do the same thing. So we can define y as null is larger than 1000, and we want to fit y on time. So LG1, logistic regression, usual one, is the GLM y tilde time, and we have to be careful that we have to specify family is equal to binomial. So default is logistic regression, and if we specify another link function, that you can fit probit model or some other models. So this is usual logistic regression, but you can go beyond the linear term. So GLM y polynomial time second degree. Again, family is equal to binomial. And also we can fit the third degree polynomial. Then you can get the summary of these logistic regressions. So the first logistic regression is here. So the time is larger, so that towards the end the probability gets lower. How about LG2? So first one is significant, but the second term, quadratic term, is not really significant. P-value is 0.09, so it's marginal. How about logistic regression with cubic polynomial? Then you can see probably the third term isn't really useful. So if you compare AIC of these three models, you can see that the second one is better than first one, slightly, only the difference is 0.8, so that isn't really large. Basically, one redundant variable is penalized by 2, so 0.8 is relatively small improvement. And the third one is certainly worse than the first one and second one. So probably the logistic regression with degree 2 is optimal for this question. Okay, so this is polynomial regression. So you can do the quiz 331-1 on Canvas. Okay, see you then.